Today we will discuss about these two problems. These two problems are related to amplitude modulation. So, in this problem, you have to calculate the power efficiency achieved by this modulator. What is the formula for power efficiency of this modulator? That means it is given by the power efficiency of any modulator is given by this. So, power of sideband frequency and power of total power of this modulator into 100%. Okay. So, to calculate the power efficiency of any modulator, you have to calculate the sideband power and the total power. So, what is the formula of sideband power? I have already reduced this formula in my class. So, here the sideband power is total carrier power into this is total modulation index divided by 2, and here this is total power is PC into 1 plus this is mt square by 2. This two formula I have already reduced in my earlier class. So here PC will be cancelled out. So if you modify this equation, so it will be mt square divided by 2 plus mt square into 100%. Now, in this formula, we have to calculate the total modulation index of this problem. So, in this formula, I have reduced it in terms of modulation index. So, our motive is to calculate this modulation index in this problem. Okay. So, here the given term is one is given is message signal. So, this is the message signal is given. So, message signal mt is given by this. This is cos omega 1 minus half sin omega 1. That means the message signal is not a single part, it has two parts. Okay, this message signal has two parts. One is cos omega 1 t and another is sin omega 1 t. So you can write this message signal as summation of two part. This is plus of minus half into sin omega t. So this is the m1 t plus this is m2 t. That means the message signal has two parts. One is m1 t and another is m2 t. That means you have two modulation index. You have two modulation index. How to calculate these two modulation index I will discuss here. Now, the carrier frequency is omega c and the amplitude modulated wave is given by this. So, this is the amplitude modulation wave. So, this is the AM wave is given by ST equals to 1 plus mt into cos omega ct, where omega c is the carrier frequency. Now, this is the AM wave given by this problem, but the standard AM wave is given by AC into 1 plus mt into cos omega ct. So if I take this is as 1, this is 2, this is 3 and this is 4. Now if I compare these two equations, okay, so comparing 3 and 4, this and this are similar, these are similar, but there is one. Okay, so here is AC, so you can write that AC is given by 1. So carrier wave have amplitude of 1. So here you can calculate that AC is 1. Now we will reduce this standard wave ST. So here this signal, that means equation number 3, you can write that ST is given by, this is AC is 1, so this is 1 plus, and this is M1T plus M22, that means this is half cos omega 1t plus of minus half sin omega 1t into cos omega ct. This is the amplitude modulated signal in this problem, given by in this problem. Now this is AC is 1 and this is AM 1 is given by half, and this is AM 2 is given by minus half. So this is the amplitude of a carrier message signal and another amplitude of this message signal, because message signal contain two parts, this is M1 and this is M2. So amplitude of this M1 is half and amplitude of this M2 is minus half. So and AC is given by 1, so MA1 is given by AM1 divided by AC. I have to only the magnitude, so here it will be half divided by 1, so it will be half, that means 0.5. Similarly, the modulation index of this A2, that means it will be AM2 divided by AC. I only need the magnitude, so it will be half divided by 1, so it will be 0.5. Now we need the total modulation index. Now the total modulation index MT is related as root over MA1 square plus MA2 square. So it will be 0.5 whole square plus 0.5 whole square, then it will be 0.5 root 2. Now from this equation 1 we can calculate the power efficiencies of this problem. Only you have to put this value. Okay, so from this equation you can write that this is MT, so this is 0.5 root 2 whole square, and this is 2 plus 0.5 root 2 whole square, so it will be 0.25 multiplied by 2, that means it will be 0.5, and it will be 2 plus 0.5, and there is a 100%, there will be a 100%, so this will be 0.5 divided by 2.5 into 100%, that means that means 5, so it is the 20%. So the power efficiencies of this problem is given by 20%. So how to solve this problem? I have calculated the total modulation index of this problem, then I only put this value of MT here, and easily you can calculate the power efficiency achieved by this modulator. Now I will solve this problem. Number 2. What is this problem? Here you see a sinusoid 10 omega ct, where omega c is 10 to the power 6 radian per second, is amplitude modulated by another sinusoid b cos omega t, where omega is 10 to the power 3 radian per second, with b is chosen as to secure 100% modulation. Write the expression for the modulated signal and obtain this C component. That means here you have to find out the expression for modulated amplitude modulated signal. So total expression you have to reduce. Okay. So what is the given term in this problem? The given term of this problem is a sinusoid 10 omega ct, that means it is a carrier wave. So carrier wave is given by this carrier wave, that means EC is given by 10 omega ct, where omega c 10 cos, this is cos not sine. Okay, this is cos not omega c, where is cos. Okay, here is cos omega c, not this is cos omega ct. Okay, so here 10 cos omega ct, where omega c is given by 10 to the power 6 radian per second. So 10 cos 10 to the power 6 t. Okay, and the message signal is given by this. Now the message signal wave is given by this. What is this? This is b cos omega t, and omega is given by 10 to the power 3 t. This is equation number 1. This is equation number 2. This is carrier and this is message signal. Now here B is chosen as to secure 100% modulation. That means here the modulation index is given. So here the modulation index MA is given by 100%. That means the value of modulation index will be 1. Now you have to modulated signal, amplitude modulated signal EAM can be written as, this is the AC and this is the AC plus AM cos omega MT into sin cos omega ct. This is the amplitude modulated signal. Now this is AC is 10 plus AM is B, this is B, this is cos 10 to the power 3t, and this is the cos 10 to the power 6t. Okay, now if I take 10 as a common, then it will be 1 plus b by 10 into cos 10 to the power 3t into cos 10 to the power 6t. Okay, now this is nothing but a modulation index. This is nothing but a modulation index. In modulation index is given by 1, so b by 10 must be equals to 1, so value of b must be 10. So if I put this value, then it will be 10 into 1 plus 10 by 10 cos 10 to the power 3t into cos 10 to the power 6t. So it will be 10, 1 plus 10, 10 cancel out. So it will be 10 to the power 3t into cos 10 to the power 6t. So here it will be 10 cos 10 to the power 6t plus 10 cos 10 to the power 6t into cos 10 to the power 3t. Okay. Now this term can be written as, here this is 10 cos 10 to the power 6t, this is carrier wave, plus you can write 10 divided by 2 into cos, you can write 10 to the power 6 as 1000 into 10 to the power 3t into cos 10 to the power 3t. Okay, so this is 2 cos A cos B, so you can write as 10 to the power 6t plus it will be 5, so this will be cos A cos B, 2 cos A cos B, the formula is cos A plus B, A plus B plus cos A minus B. So it will be 10 into cos 10 to the power 60 plus 5 cos, it will be 1001 into 10 to the power 3t plus it will be cos 999 into 10 to the power 3t. This is the 3, this will be 5. Okay, this is the 3 part of or component of this amplitude modulated signal. This is the upper sideband and this is the lower sideband. Okay, this is upper frequency and this is lower frequency.